Lesson 5 of Chapter 5, Day 2, is going to be on the half-angle identities. Before we get to those, let's review for a second the double angle identities. We've got one for sine, we've got one for tangent, and then we've got three separate ones for cosine. Sometimes we use the top one for cosine, sometimes the middle one, sometimes the bottom one. Kind of depends what else is in the equation. So, if you look at this equation, talked about this yesterday, this one says solve, and hopefully this guy right here jumps out. We're going to use a double angle identity to change out the cosine of 2x. So, since the equation has a cosine squared, I'd like to use this middle one right here, 2 cosine squared of theta minus 1. Now I'm going to have to distribute that negative sign, so that's going to give me cosine squared minus 2 cosine squared. See, I've got x's here, not thetas. Let me just fix that real quick. Get rid of that theta, make it an x. Okay, and then that's going to become a plus 1 equals 1/2. Well, we've got like terms here. If we combine the like terms, we get negative 1 cosine squared of x. If I subtract 1 to both sides, we get a negative 1/2 on the right. And now if I divide both sides by the negative 1, we'll have cosine squared equals positive 1/2. Square root both sides. Cosine of x would equal plus or minus the square root of 1/2. And again, the square root of 1/2, that becomes plus or minus the square root of 2 over 2. And since that equals the cosine of x, my answers would have to be 45 degrees, 135, 225, and 315. Those are my answers between 0 and 360. Next, we're going to get into half-angle identities. Before we do that, you guys know that recently we celebrated the day, the Pi Day, March 14th, because the date is 3.14, or 314. A little something about pi that you may have never known. Why should you never get in a conversation with pi? Reason being is because he'll just go on forever. Get it? Goes on forever, pi. Okay, here's your half-angle identities. We have one for the sine. We've got one for the cosine. And then we've got three separate ones for tangent. Now, why do you suppose these identities are called half-angle identities? Because the angle theta is being divided by 2. It's being cut in half. So these are our half-angle identities. We will use them to simplify problems and also to solve equations. So should have those on your note card. We'll start off with finding the exact value for 112.5 degrees. So I'm going to use the half-angle identity. I've got it down in the bottom right-hand corner. First of all, the cosine of 225 degrees, which is on our unit circle, divided by 2 is equal to the 112.5 degrees. So if we look at this formula, the first thing we have to do is figure out the plus or the minus. Since 112.5 degrees is in the second quadrant, since all cosine values in the second quadrant are negative, I'm going to have a negative sign in front of this square root. I'm going to have a 1 plus cosine of 225, all divided by 2. Now what I'm going to do is I'm going to substitute in. The cosine of 225 is equal to negative root 2 over 2. And now this is my answer, except for I need to simplify it. So to simplify it, what I'm going to do is I'm going to first break it apart. Now, if you're wondering where that 4 came from, if you take a look up above, we've got the square root of 2 divided by 2, but then that's being divided by 2 again. And dividing by 2 twice is like dividing by 4. Now I'm going to take these two fractions and I'm going to put them together. So we get 2 minus the square root of 2 all divided by 4. And that's a really good answer, except for I'm going to actually square root the bottom. And so I get something like this, all divided by 2. This is my exact value. And now what I'm going to do is I'm going to go to the calculator and I'm going to check to see what decimal value this is equal to. So we're going to have something like this. 2 minus the square root of 2 divided by 2. And so since that gives us a negative 0.3826, Now to check to see if that's right, let's compare it to what we originally were given, the cosine of 112.5 degrees. And if I type in the cosine of 112.5 degrees, I'm pretty sure I'm in degree mode, yes. And that should give us the same decimal, and it does. So it's a way of checking your answer. Next one, let's do the same thing, but this one is a sine of 75 degrees. And 75 degrees is exactly half of 150 degrees, and that's on the unit circle. So I'm going to use a half angle identity to find the sine of 75 degrees. I've got the formula down in the bottom right-hand corner of the screen. We're going to have to figure out the plus or minus first. Since 75 degrees is in the first quadrant, and since all sine values are positive in the first quadrant, we need to have a plus sign in front of this square root. We're going to go 1 minus the cosine of 150 degrees. I'll divide it by 2. Now if I plug in my unit circle value, the cosine of 150 is equal to negative root 3 over 2. And now simplifying this, what I'm going to do is I'm going to break it apart and then put it back together. So we get 1 over 2. The double negative changes to a plus, and we'll have root 3 over 4. Putting those two guys together now, the common denominator is 4. So we're going to have 2 plus the square root of 3 all divided by 4. Then I can square root the bottom. And so here's my answer. And that should be the same thing as we had earlier, except for it's not going to be negative. So if I go up here and grab this, and if I just eliminate that negative sign in front, and then hit enter, you can see we get 0.38. And if we compare that to the sine of 75 degrees, which was originally given, we get, whoa, did I type in the wrong thing? Sine of 75 degrees. All right, where did I go wrong? 2 plus the square root of 3. Oh, that's the problem. I've got, okay. Let's go up here and grab this. I also need to change this into a square root of 3, don't I? There we go. Now you can see. And I also need to change this. Oh, this is funny. Okay. Change this to a plus sign. Now we should get the 0.96. Finally, got it. I'm glad you got to see the struggle is real tonight as I'm doing these videos. Let's do another one, but let's do it with tangent of 7 pi over 12. 7 pi over 12 is exactly half of 7 pi over 6. If that's too difficult to work with the fractions and radian measure, you could take the 7 pi over 12 and you could change it into degree mode, which is 105 degrees. And so if it's just easier, you can do this as the tangent of 210 degrees divided by 2. Same concept. The left one's in radians, the right one's in degrees. Now I've got the formula down below. That's the one I'm going to choose to use. We've got 3 different formulas we can use. This one I think is the easiest to work with. So it's going to be equal to 1 minus the cosine of 210 degrees divided by the sine of 210 degrees. So now if I plug the unit circle values in, we're going to get 1 minus negative square root of 3 over 2, all divided by the sine of 110, which is negative 1/2. So I got to simplify this answer, and the double negative on the top is going to give me 1 plus the square root of 3 over 2. And then I'm going to take that all times the reciprocal of the bottom, which is negative 2 over 1. If I do that, I'm going to get negative 2 minus, let's erase that, negative 2 minus the square root of 3. This is my answer. If I type that in on my calculator, should be the same thing as the tangent of, what was it, 105 degrees. So we get the same thing. Great way of checking your answer. Now, we're going to finish with using these half-angle identities to solve trig equations between 0 and 2 pi. So when you look at this problem, hopefully what's going to stand out to you is this guy right here. That is a half-angle identity for cosine. I'm going to use this right down here in my problem to solve. So I'm going to keep that sine squared of x on the left-hand side. we got this 2. I'm going to change the cosine of x divided by 2 squared into an expression that's still squared because of this square. But I need to have this plus or minus square root of 1 plus cosine of theta over 2. Actually, it's an x. So let me erase that theta and put an x in. Well, the really nice thing about this is that the square root and the square are just going to cancel each other. In the same way, this 2 on the bottom and this 2 in the front are going to cancel. So we're left with sine squared equals 1 plus cosine of x. Now, we've been solving equations like this. We don't like to have a sine squared and a cosine in the same problem. So let's use the Pythagorean identity. Sine squared is equal to 1 minus cosine squared. If it's easier at this point to change these into m's, we can do that. I'm going to get everything onto the right-hand side, giving me m squared plus m. I believe the 1's would just cancel out right here. There's a 1 on the right and a 1 on the left. And so now I can factor this, taking an m out. It leaves me with an m plus 1. And so m would equal 0, and m would equal negative 1. Well, instead of m's, we're working with cosines. So cosine of x equals 0, which means 2 of my answers would be pi over 2 and 3 pi over 2. And since cosine of x would equal negative 1, we'd have an additional answer at pi. So this is solving a trig equation using a half-angle formula. Let's do one more problem like this. Hopefully when you look at this, you can recognize that we're going to have to change this guy right here using our half-angle formula for sine. I've got it in the bottom right-hand corner. I've got this 2 in front. I got the plus or minus square root of 1 minus cosine of x, all divided by 2. All this is squared, plus cosine of x equals 1 plus sine of x. Well, again, I like the way this looks. The square root and the square are going to cancel. This 2 in the front and this 2 right here are going to cancel. So it looks like I'm left with 1 minus cosine of x plus cosine of x equals 1 plus sine of x. Looks like this is going to simplify real nicely because I can cancel these cosines, and I can also cancel this 1 with this 1. And so it looks like I'm left with just 0 equals sine of x, and sine is equal to 0 at 0 and pi. So we get 2 answers on solving that trig equation. So day 2 was using your half-angle identities. We've got one more video to watch, which is day 3 on sum to product and product to sum identities.